So that's it. So I wanted to keep that part of it short in case anyone had questions. Thanks. Well, it's a little bit different than geothermal because rather than having a well that goes deep enough that you can tap into essentially hot water, we're using actually the temperature differential between with the cold water, and you can do that. Well, the way I understand it, not being a mechanical engineer, you can do that a number of different ways. One of the ways is a ground source heat pump, which are fairly shallow wells that take advantage of this temperature differential of water that's just in the ground. One of the times we've incorporated that is actually in the caissons, in the footings. For a tall building, if you have deep caissons that are going down to support the load of the tower, you can actually install piping in a fairly straightforward way in the hole that you're drilling for the caisson that'll admit cold water essentially, and you can use that temperature differential essentially in a heat pump to help heat or cool the building. When you have an adjacent water source like the lake in the case of Lake Michigan or the river in the case of the Virgo building, you can use that water, the temperature differential there. The only big issue actually is a different sort of environmental one, where environmentalists are concerned that if in the water that you put back is going to be warmer than you took it out. And there probably are people in here that are more qualified to talk about this than I am, but my rudimentary understanding is if you put back the warmer water, it affects the natural life, and you have to temper the water that you put back so you don't kill off fish and so on. But usually the difference in temperature is not so great that it creates a problem as long as it's a big enough water source. Yeah. Oh yes.
Hi. Mike Bobker from the CUNY Building Performance Lab. You mentioned a couple of times the importance of airflow through buildings and controlling airflows, and the stack effect in high buildings is really a major issue from an engineering point of view, maintaining conditions. Could you comment on what happens as you introduce these undulating forms to sealant technologies on curtain walls and all your your external skin over long term? Because once those seals start to fail, then whatever the mechanical engineer has tried to figure out for HVAC control is really kind of out the window as you get these uncontrolled kinds of things. So what's the state of the technology? Is it keeping up with the new forms that you're kind of introducing?
Yeah, out the window, no pun intended, right? I think it's a great question, and it is a big challenge because as people try to do these forms that are more unusual, it challenges the industry who's accustomed to building curtain walls, not like this curtain wall at all, but more like this curtain wall that's rectilinear and straightforward. I guess part of the answer to that question is that many of the buildings that we're doing now actually have operable windows. So our mechanical engineers are in a tall building challenged by the stack effect and what it means to open a window in a tall building because of the pressure that's built up in the building, like you're saying, it creates a stack effect. And if you just open up the window like you have in your house, all your paper is going to go blowing out the window. We've created in a number of cases sort of mullions that have a rotating component in them that allow you to take in fresh air without having a large window that you have to pull open. But it's a mechanical challenge. I think the issue of the curtain wall, although what is kind of interesting about the industry now, because everyone is so accustomed to building curtain wall, it's never been cheaper to put curtain wall on a building, except for the fact that the Chinese are using so much of the world's natural resources that's driven the cost of all the aluminum up. But people or manufacturers are set up to build curtain wall very efficiently and effectively now, and there's a huge pressure to use just products on the market because it's so much more economical than redesigning them or creating a new idea for how the curtain wall works. But in spite of the fact that we are going to be relying on sealants for a lot of our projects, or for the integrity of our projects, we've been able to, because we have in-house curtain wall experts, we've been able to engineer the joints between the components of the exterior wall to allow for a minimum amount of problems in the future. And actually, we just recently had a test, a window wall test for a facade that had a curve to it, and there was a special profile to the aluminum in order to make it work, and it passed the test, which was great, and everybody was happy. And as they started to dismantle it, they realized that they hadn't even bolted it together. So that they ran the test, and it was just silicone that was holding the whole thing together. So, I don't know, hopefully our sealants aren't all going to fail on us. Thanks. Yes.
The design, I think, of North Bund has, for lack of a better term, sort of an expanded honeycomb system over it. Does the curvilinear and sort of unusual by standards, I guess, here in many places, effect of that curving, does that help you with the different orientations of the building? Because in certain orientations it's good to have it horizontal, others it's vertical. In this instance, you sort of have a combination of both of them.
Well, I guess the best response is that the idea was to create this curvilinear texture that, as you look at it in elevation, had a relationship to what's happening in plan, because the plan was curvilinear. There's another piece of the story which is going to seem very arbitrary, but it was important in terms of getting approval for the plan. Now, that particular site, this North Bund site, has been known as the Magnolia site for about the last 15 years, as they've been anticipating it being developed. And one of the things that the planners kept saying to us as we came back with different variations on the scheme, that it's very important that you respond to the idea that this was the Magnolia site. So actually the shape of the plan with the two shapes overlaid is reminiscent of the shape of the magnolia flower, and the surface is based on the bud of the magnolia. There is when the magnolia is in bud, it has a kind of a honeycomb texture to the surface of it, and that's what inspired us to do it. Ultimately, the effect of it is going to be to shade the building, but we were looking for a good way to respond to this desire by the local municipality to somehow represent the magnolia, because what we were afraid of is that they were going to tell us to kind of arbitrarily just stick a flower up on top of it or paint magnolias on the side. So we tried to integrate this idea in. But we thought that the sort of the curvilinear shape had a great relationship to the plan, and also there's I didn't want to get into feng shui, but in China, this building would be very difficult to get built. Anything with sharp corners on it, because it's seen as at best impolite to point towards your neighbors with a sharp edge. So quite often these curvilinear shapes are seen as much more friendly, and people really prefer to see a curvilinear shape. So it was another reason why we have this kind of organic curvilinear vocabulary to that particular building. The microphone is moving around.
Most of your lecture involved site-specific conditions, usually dealing with heat and sun. So it was interesting to see the Tyrol Tower. And I was wondering, we didn't really hear specifically, you're talking about a very different climate, how that responded.
About that climate?
Yeah, so instead of being equatorial with a lot of heat and a lot of sun, like we're talking about a tower, so the shape is similar to what we saw in the hot places, and you did mention it was going to try and be carbon neutral. How was it site-specific?
Well, in this case, we haven't been able to push it as far as I think we'd like to, and this particular project still is still evolving. But what I didn't describe is that the skin of that building is actually a double wall, and what we found, and this is something that actually we're working pretty hard on right now, and I think it's important to us being in Chicago too, where it's so cold most of the time. But what is the climate-specific response that's like putting a sweater on the building? You know, so that these sun louvers and so on are like the baseball cap. But what is the architectural equivalent of the scarf or the sweater, or what is the thing that's going to keep you from experiencing the cold sort of radiating through the glass? And the best response I think we've found for that so far is a double wall, and that particular building has a double wall, and you can actually make a double skin wall work well both in a hot climate and a cold climate. It's kind of like a thermos bottle. So it's the closest analogy I can think of for that one is this thermos bottle where you have an exterior layer of glass, an internal layer of glass. There's an airspace in that particular building of about a foot between the two of them, and that allows you to temper the air that's between the interior and the exterior. The other thing it allows you to do, because that particular building has all operable windows, the external facade has gaps that allow the air to circulate in it, but it still stays somewhat warmer than the outside air in the case of the winter, and somewhat cooler in the case of the summer. But it allows you to open up the windows without having this issue of gusts coming in from the stack effect I described earlier, because you open up your window into the air gap. So those are some of the kind of technology we're using in that building. I mean, I think that one is somewhat less successful in having an appearance that is different than somewhere else. It is less kind of a site-driven appearance than perhaps some of the other projects were. But the thermos bottle, I guess, is the best way to describe the environmental approach.
I think maybe we better stop there. Let's just thank Russ again.
Yeah, you've had enough anyway. I just want to thank all the SOM people for not heckling me.
And we're going to have a reception now back out where you came in.